Zeddy, can you respond to that?
Yeah, I can say, okay, from literature, I read that at lower acidity of 5 and below, that is the recommended acidity of the catalyst that will actually produce a higher level of liquid oil when used in pyrolysis. 5 and below.
Okay, thank you for that response. I think members, if there are no more questions, then we can move to the next presentation. Thank you, Zeddy, for your good presentation and the response to the questions. You may stop sharing.
Thank you.
So the next presentation on our program is from Samuel Kusasira. Is Samuel present? Samuel Kusasira. Do you have Samuel Kusasira?
I can hear somebody talking from background.
Hello?
Hello, can you increase your volume?
Okay. The volume seems to be higher. Hello?
Yes. Samuel.
Hello?
You are still breaking. If you can still check your volume.
Okay. Good morning.
Yes, now we can hear you, Samuel.
Okay, thank you so much. Is my PowerPoint shared?
You can start sharing your PowerPoint.
I have shared. Is it visible?
It's not visible yet.
Okay. I go to share. Share. Then is it now visible?
Yes, it's loading.
Okay, thank you so much. My name is Samuel Sasira from Kampala.
I don't know about the other. It's loading.
Is it loaded?
Yes, it's there now. We can see it. You can see it.
Okay, my name is Samuel Sasira from Makerere University Business School, Kampala. Founder of 4Energy Connect Uganda Limited from Makerere University Business School, Kampala. Co-implementer of 4Energy Connect Uganda Limited from Makerere University Business School. The topic for study is of 4Energy time series analysis of socio-economic determinants. The topic for study
Sorry, Samuel. We cannot see the presentation.
Sorry.
Samuel, we cannot see the presentation. We cannot see the presentation. Please share it again.
Sorry.
Samuel, we cannot see the presentation. We cannot see the presentation. Please share it again.
Sorry.
Samuel, we cannot see the presentation. We cannot see the presentation. Please share it again. Yes, you're there now. We cannot see the presentation. We cannot see
It's not in the play mode. Could you press slide shoe and play? Thank you. In the play mode, could you press slide shoe and play? Thank you.
Am I able to play it?
Press slide shoe and play. Thank you.
Just go to
Go to slideshow. Thank you.
just go to slideshow. Just go to
Go to slideshow.
just go to slideshow. Just go to
Go to slideshow.
So my name is Samuel
Sorry, it's not work.
It's not there. So my
Not
name is
work.
Samuel
Did you press the slideshow and then play shoe?
It's not there. So my
Not
name is
work.
Samuel.
Did you press the slideshow? If it not work, please press view. The up button. View. Then not work, please press view. PPT. View. Press view. Can you press view, please? Press view. The button view. View. Press view. Can you press view, please? Press view. The button view
at the top.
View at the top of your PPT. Can you press view, please? Press
I
view.
think
The button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please? Press
I
view.
think
The button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please? Press
I think
the button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please? Press
I think
the button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please? Press
I think
the button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please? Press
I think
the button view
I don't know whether you're able
at
to
the
see
top
that.
of your PPT. Can you press view, please?
We can see you.
Yes, yeah, good.
Thank you.
Yes, good to see you,
We
Professor.
can see you. You're welcome. You must have been in
Yeah,
the
good.
team that visited
Yes,
Moi
good to
University
see
the
you,
other time. We
Professor.
can see you.
Oh,
You're
I
welcome. You
was
must have been
supposed to be among
in the
them, but
team
I
that
missed,
visited Moi University
unfortunately.
the
I
other
was
time.
doing my
We can see you.
exams. I
You
was
must have been
supposed to be That's among how I
in
missed,
the team that visited Moi University. Okay. But you are
Yes.
welcome all the time.
Thank you so much. Yeah, I'll be glad.
So as my co-chair, maybe we could just go ahead and check whether the other presenters are online.
Okay.
We are expecting also Dr. Harun Said.
Yes.
Could he be around? Dr. Harun Said? Okay. We are also expecting Joan Jepkosgei. Are you around? Okay. Then Dr. Chundao Lan. Dr. Chundao Lan.
She is coming. Just wait little several minutes. She will coming. Yeah.
Okay. You'll be there. Good. So now it is time, therefore, that we start our side of symposium. We are happy to invite Brenda Akankunda all the way from Kampala.
Yes.
And thank you. You are welcome. And we shall be having our session. We expect you to present in 15 minutes, so as you can give time for around 5 minutes for questions and answers. So,
okay.
Brenda, you are welcome to give us your presentation.
Okay. Yes, thank you so much. Good morning, everyone. I take this opportunity to welcome you once again to this session. I hope my presentation is seen, is on.
Yes, we are seeing it. It's on, yeah.
Okay, great. This study is on industrial outputs in Uganda and does electricity consumption matter? This paper was presented or it was submitted to the industrial theme but it is basically about sustainable development and consumption. So my name is Brenda Akankunda, and I carried out this study with other authors, including Professor Adaramora and Professor Engelsel. So we'll take you through the following presentation layouts. And we begin by taking you through our Ugandan industrial sector. This industrial sector has the electricity demand of about 64.6%, and its value added of the GDP is currently 19.9, whereas the competitiveness index is 3.7. The government of Uganda has tried to increase electricity transmission and generation, and currently we have the installed capacity of 1,252.3 megawatts, whereas the maximum demand is 723.76 megawatts, which we really see that there is a lot, there's a big question on this, because what is generated is actually not consumed. The industrial sector has experienced low output, it has poor quality, it has experienced low sales, but all this has been attributed to unreliable power supplies, because all these affect sustainable productivity and consumption by these industries. So like I said earlier on, the share of the value added to GDP has been declining from about 53% to now 24%. And the sector contributes only 20%, yet its counterparts, for example, the service sector, is about 48%. And this industrial sector, ladies and gentlemen, is dominated by small-scale firms that are providing limited value addition. Now we begin also by saying that industrial development has been an engine for any economy that desires to move from a non-industrial state to an industrial state. But however, to achieve this, certain factors must be put in place to trigger this achievement. And among these factors is availability and reliability of the energy resources, and that is electricity. The industries in Uganda, 80% of them rely heavily on electricity for their operations. But yet we continue to see them suffering from all these electricity interruptions that are ongoing. But however, limited empirical studies have been carried out to explain whether electricity consumption matters for industrial growth. So like we have said in the background, the Ugandan industrial sector has suffered from unaffordable and reliable power systems, and all these have been categorized with high power interruptions, and as a result, these industries have experienced loss in output, low value addition, and high operating costs, as it has been put by the World Bank. In the recent World Bank Doing Business, Uganda was ranked as 127th out of 190 economies. The government of Uganda, through its power sector reforms, has tried to put a lot of efforts in generation and transmission, but the consumption mechanisms have duly ignored, and yet this is a big concern. It is a big concern because electricity has been highlighted as the most common chosen top obstacle, especially the cost of electricity, which is currently 17.10 US cents per kilowatt. And all this is affecting industries. They cannot afford this big cost. It is now anticipated that our study, the findings from this study, will add to this gap to help explain the consumption mechanisms that the government and policymakers can do to help these farms improve their industrial output while consuming electricity that is reliable and affordable. Ladies and gentlemen, this study's aim was to examine how electricity consumption influences industrial output. This study was also guided by the following methods and materials. This study used time series data, which was obtained from World Bank surveys, including the World Bank Doing Business of 2019. But you know, time series have a little bit of limitations, and one of them is spurious results. So we managed this by testing for normality using the Jack-Bearer statistics. We also tested for stationarity using the augmented Dick-Fuller to test for unit roots. And we went ahead to carry out a co-integrated vector autoregression to estimate the model. And then we also used the vector autoregression to run a long-run relationship between industrial output and the other variables, which was electricity consumption, education, and the labor employed. Ladies and gentlemen, these are our key results. And from the results, we discovered that, in fact, electricity consumption matters for these industries to develop. Education is very key, and also labor employed is very key. And from this model that was estimated, we have an adjusted R squared of 41.5%. So from our study findings, we specifically find that electricity is a necessary condition for any industry to survive. And we estimated a Cobb-Douglas, an augmented Cobb-Douglas production function with all its variables: electricity, education, and the labor employed. And when you look at our results, they presented a long-run positive relationship. And like I have mentioned, we found evidence that when industries employ well-educated workers, then they become more productive and industrial output can be achieved. And then we also find that when these workers that are employed are in a good position, that the labor mixes are good, then the industrial output will also improve. Ladies and gentlemen, these findings support area theories like the production theory, but it also supports the area studies, which have consistently shown that electricity consumption, education for the workers, and the labor employed have a long-run causality on industrial output, as the following authors have indicated. So from the study, we therefore recommend, since electricity consumption matters, the government and policymakers should invest in consumption mechanisms such as through subsidies, so that the current electricity tariffs can be affordable to these firms, but also provide reliable electricity supports, because currently the main source of electricity that we have is from hydro, yet we know that there are other many alternative sources that can supplement or help industries to go on. But we also recommend that there should be joint industry energy inter-service task forces, whereby our regulators in the energy sector should really be in touch, should encourage and train these industries to access and use electricity so that they can achieve sustainable production and consumption. And then, ladies and gentlemen, since we found that labor employed also matters, or it has a long-term relationship on industrial output, we also recommended that there should be focused efforts on the labor employed mechanisms that can help these firms to increase productivity, such as accelerating learning processes for dynamic capabilities at all levels, that is both micro, meso, and macro levels of these industries. And we also encourage production automations so that they can make the production effective but also competitive on the market. And then, since the study also found a positive and long-run relationship on education, we encourage industrialists also to offer on-job training and skills development to their workers, but also to adopt the value addition learning strategies through trainings, through workshops. And we also encourage the firms to strengthen the institutional framework. This is for policymakers and capacity building for advanced capital equipment and machinery to enhance production automation. And when all this is done, we highly believe that industrial output will be achieved by these industries. So we go on to conclude by saying that the study results suggest that industries that consume electricity will actually have a higher output than their counterparts. And you also conclude that well-educated workers with productive labor employed will produce more because they contribute more to the farm output. And the key positive results that emerged from the findings is the important role of electricity consumption holding other factors constant. So the results imply that the estimated results from our vector error correction model, they provide a good estimate of a real industrial output differential, at least for workers in the agro-based industries sector. I thank you so much for listening, and I'll be glad for your positive feedback. Thank you so much.
Prof. Thank you, Prof. Welcome for my presentation. My name is John Jeb from Moi University, Department of Manufacturing, Industrial and Textile Engineering. I'm going to present, my title is The Use of Solar Evacuated Tube as an Alternative Methods of Drying. My supervisors were Isaac Mchilwa, Jerry Ochola, Owino Jojo Molo, and Professor David Twigong. So my outline will include introduction, aim and objective, justification, methodology, results, finding and discussion, and also conclusion. So my introduction is that we commonly grow maize in Kenya or in Africa, and it's a staple food for Kenya, which is mainly the source of energy and source of income to most of the farmers. So once these maize are harvested, they always have a high percentage of moisture content, which is ranging from 28% to 34%. Hence, that one will lead to growth of microorganisms if stored without drying. And once these microorganisms, such as mycotoxins and aflatoxins, grow in this product, they end up damaging the physical property, which includes the color of the crop, or the crop will lose its nutrition value, which includes the taste and the smell. So we need to dry this maize for it to have a ease storage and also ease in processing, and also to minimize the growth of microorganisms. The minimum amount of moisture content that is required for this particular product, like maize grain, is 13.5%. So that even if you go and sell to other processors, that's the percentage that they require. So factors which affect drying will include temperature, relative humidity, and the moisture content. So the aim of this research was to design and fabricate a heating system using solar evacuated tubes to produce heat that can be used to dry farm products. So justification. Drying is classified into two. There is natural drying and there's mechanism drying. In natural drying, we have solar dryers, which includes spreading the products over a flat sieve or plastic sheet or cement. The disadvantage of using this is because the products will be exposed to insects, rodents, and birds, or even rain showers in case it's on a rainy season. But we can also use in-crib, which is storing the product in a perforated room. This one, the disadvantage is that it takes a lot of time to dry because the products are already packed and there's low airflow. In mechanized drying, we have shallow bin, we have shallow layer, we have bin, batch in bin, and fluidized beds. The disadvantage of this is that there's a lot of energy and fuel consumption. We have a group of solar dryers which falls under direct solar dryers, which uses commonly the greenhouse effect, or indirect solar dryers, which we use solar flat plates or the solar evacuated tube, and we have the mixed mode solar dryers, which combine both the direct and the indirect. With this one, the disadvantage is that it has high installation cost, and it also depends on sunshine. Here. From my system was, I had to find a solar evacuated tube and also create a manifold. So my solar evacuated specific include that it's made up of special selective coat. It's made of aluminium, and its internal diameter is 47 meter. External diameter is 0.057. It is a one open-ended tube with a length of 1.8 meters, and it has an absorbing area of 3.7 meters square. The manifold is made up of the frame, which is made of wooden, and its measurement was 0.74 by 0.1 by 0.196 meters. This was for the fact that it will hold the tubes in place and keep it safe from damage. And also I had solar pipe that are made of aluminum pipe, which is a good conductor of heat. So how does this system work? Is that the air is being blown into the system by the blower. This air enters through the aluminum pipe and out through the internal part of the solar evacuated tube, and then into that chamber where we can see the circular pipe, and then out. So the temperature which was being measured was the environment temperature, which is the ambient temperature, and the temperature that we get at the end of after it has gone through the system of solar evacuated tube. So this is the graph that we got from the test was done for about 2 days. This is because different days have different UV intensity, so we got different temperatures and relative humidity. So as we can see at the inlet, the temperature was as low as around 21.7, but as the day progressed to around 12:45, the temperature at the ambient temperature was 26.2, and in the evening at around 4 p.m. the temperature was 21.5. The relative humidity was at 10 a.m. was 64.7, which decreased at 12:45 to 48, and at 4 p.m. it was 67.2. But after the air with that temperature variation through the system, the temperature was able to increase as time passed by. Like in the morning, that 10 a.m., the temperature, which was 21.7, was able to be raised to that 7.5, and at 12, which is midday, the temperature was raised from 26.2 to 56.7, and at 4 p.m. it was raised from 21.5 to 43.6. So the relationship between the temperature was that, and the relative humidity was dropping as the temperature was increasing. Hence, when the moisture was dropping, this could actually allow more room for, if it's being used for drying, that air which is being used for drying, it could be able to absorb moisture from the product that we were drying. So from my research and the variation, I was able to fabricate increase the temperature of the air to the highest temperature, which I got 56.3 degrees, and the relative humidity, which dropped to 42.1 in the midday. This one, from my finding, is that the temperature that is needed to dry, such as maize grain, is between 30 to 60 degrees, of which I was able to get 56.3 degrees, which I believe that my system could actually dry a farm product. Hence, I would recommend that if people would be able to use the solar evacuation, or research can be done on using a double open-ended solar evacuated tubes. So there is my reference for listening to me.
Hey, thank you, Joanne, for that good presentation. We now welcome questions from the listeners. Any question?
Yes, Professor.
Yes, Brenda?
Yeah, I just wanted to find out from Joanne. Joanne, thank you so much. The presentation is good, and
thank you too.
And the study is quite good as well. So I wanted you to make clarifications in the methodology. Was this an experimental study? And which type of experiment did you carry out?
Okay, it was an experimental study which it was a qualitative research where I wanted to find the variation on the temperature change after using the solar evacuated tube to achieve a particular temperature that could dry my farm products.
Okay. Oh, that's very good. Maybe you could mention it clearly under your methods.
Okay.
So that it can come out clearly and it can guide the reader to follow. But thank you so much for that.
Thank you, Madam Brenda.
Thank you, Brenda and John. Any other questions? We have enough time to ask Joanne 100 questions.
Yes. Yes, Joanne, you could take me back to the results.
Okay.
Because I have a lot of interests in this. That in Uganda we have a lot of maize.
Yeah.
And this can be really I can learn from here. Yes.
Am I there?
Yeah, that is okay. That is fine. So you are comparing a variation between temperature, humidity against time.
Yeah.
And you're looking at the solar tubes. And you are looking at drying the maize, if I'm clear. So what are you aiming? What is your outcome?
Okay. From the main reason why I did this research is because when it comes to solar drying, there's the one which people use the flat plate, the flat plate collector and the solar evacuated tubes collector.
Sure.
So the solar tubes collector are commonly used to heat water in the house or even warm houses, like in modernized country, right?
Yes.
So I picked solar evacuated tube, which hasn't been done when it comes to drying of the farm products. So the reason why I was in this research, I was specifically concentrating if I can achieve that temperature that can be used to dry the maize. And the appropriate temperature, like for example, using maize is between 30 to 60. That's when we can actually be able to dry the maize grain. That if it's higher than that, either it will damage the physical property of the maize grain, or if it's below, we cannot achieve drying it at optimal. So when I organized my solar evacuated tubes, I wanted to first achieve that particular temperature. It should range between the 30 to 60, which I really need to dry for my grain. That's why I did that one. So first I was using this, you measure temperature at the inlet, which is the ambient temperature of the environment, which is going into the system, right? And testing the temperature that comes out of the system, which is what now I would use it for further research, like how to dry my products and 1, 2, 3, right? So in this research, I was just concentrating on achieving the temperature that I needed to dry my product, which is the end product.
Okay. All right. Thank you.
Thank you very much. This machine of yours, how much maize can it dry in a day?
From the research, I dried my like 20 kg. I'm yet to.
Okay.
I dried 20 kg within 1.5 days.
Okay.
And I was drying during the rainy season, which was around June, July. There. Yeah.
Okay. Then I should look for you so as I can be drying my maize in the garden.
Absolutely.
Yes.
You're welcome.
Thank you very much, Joan. Brenda.
Brenda and Prof. The other guest.
Thank you, Joan.
Thank you, Prof.
So now we can go to the next the presenter. Brenda, do I give you the opportunity to invite our next presenter all the way from China?
Yeah, sure, Professor. I will take
Yes, please.
The opportunity. So I take this opportunity to invite Dr. Chuntaolan to present to us about carbon-based coating fabrics with high conductivity for excellent electromagnetic shielding performance. You're most welcome. I think we have 10 minutes for the presentation, and then the remaining time is for the interaction with other guests. So you're welcome. So maybe, Joan, you could end your presentation.
I'm seeing like...
I'll stop sharing.
Okay.
Good.
Thank you. So you're welcome.
Are we okay?
Yes, Joan, we are okay.
Yes.
It's now time for Dr.
Should I also remove my video?
It's okay. You can. So, Doctor, you're welcome. We are waiting to hear from you.
Hello, Professor.
Hello.
Hello,
welcome.
This is Chuntaolan.
Looks like there is a technical problem, but let us be patient.
Okay.
Hello, Dr. Lan. The share button is the third one.
Hello.
Hi, could you help me?
在视频最下面，然后有第三个那个按钮
是吗？
对，然后共享桌面，你打开了以后，在最左边有一个那个桌面，点击桌面，你的桌面就被共享出来了。
哦。
Brenda, can you translate?
Oh my God. Oh, maybe in my. You can.
现在是我开始了吗
Good.
Oh.
对，我们可以
Yeah.
看到
Hello,
也开始。Yes, we can see it, and you can start.
can we start here?
Yeah, sure. You can start with you.
Looks like the sound is not coming through.
Yeah, I can't hear anything.
Hello. Yeah, the sound is not coming through. Ciele?
Yes, Dr. Chuntao. Hello. Hello, Dr. Chuntao.
Hello. Could you
Yes,
hear me?
Yeah, we are hearing. Continue with the presentation.
Okay.
Maybe can start?
Yeah, you can start. Just
If she can start again, she can start again.
Can go to the beginning. Yeah.
I'll try from the beginning.
Yeah.
Is that okay?
Yes.
Sure. It looks like we've lost her again. I can't hear her.
蓝老师，您在分享的时候，那个有一个勾的选项，然后上面是选择电脑音频，现在播不出来，应该是声音没有录到电脑里面。
哪个地方选择音频？
你再重新共享一下桌面，然后在桌面的那个窗口上面有一个勾，一般来说有一个勾。Sorry everyone, I think the problem is the audio is not from the computer.
Okay.
Yeah, so we could not hear anything, but we can hear the voice from Dr. Lan, so it means the computer voice is good, but the field audio is not.
Rapid development of electronic devices. Could you hear me from the?
Yeah, we hear you.
Yeah, we just go now from the beginning. Start.
Okay. Okay, I'll restart it.
Yeah, I'll start it.
Okay, thank you for your patience. You give me this opportunity to present here. Today, I'll introduce something about carbon-based coating fabrics with high conductivity for excellent electromagnetic interference shielding performance. With the rapid development of electronic devices and wireless communications, the electromagnetic wave have existed on the Earth everywhere. It also brings risks for human beings, such as skin problems, cancer, headache, heart problems. To solve this problem, one popular method is using conductive fabrics for EMI shading. There are two approaches for the fabrication of conductive fabrics. First is blending. This method uses the conductive fibers such as metal, carbon fibers to blend with commercial fibers to protect the human beings from the EMI shading. But for these materials, its poor processability no flexibility and heavy weight because of the high stiffness and high density of the metal materials. Another approach is coating. This method is using conductive composite coated on the commercial fabrics. This process is easy processing and plenty building blocks for coatings. There are mainly three kinds of materials for coating. The first is metal coating. This kind of coating always using the nanowires or nanoparticles of metals to deposit on the fabrics. This kind of coating is easy to corrosion and it reflects the electromagnetic wave by this fabric. And another one for the coating is intrinsic conductive polymers. Because of the polymer, it is hard to fabricate only by the polymer, and the conductivity of the fabric is relatively low. And with the rapid development of the graphene, carbon black, and carbon nanotubes, carbon-based coating has emerged as a promising candidate for EMI shading fabrics. This kind of coating is stable and always inhibit good EMI shading performance. And lightweight and high performance are true character for the next generation of the EMI shading fabrics. From the equation for shading efficiency, we can see that the higher conductivity will result in a higher shading efficiency. But for the nano composite, the content of the nano thinners is always low because of the process steps. Therefore, for my researchers, they will increase the thickness of the coating, which will decrease the performance and increase the weight. So if we want to achieve the lightweight and high performance of shading materials, we need to achieve the high conductivity with no thickness of the coating. And the optimization of coating structure is one important method to achieve the lightweight and high performance of EMI shading coatings. In this way, we use a layer-by-layer assembly for CNT coatings. Here, we use CNT and pH as a building block for EMI shading fabrics, and the obtained fabrics using a high CNT content, which reached 85.4%. However, the EMI shading efficiency of the fabric only reached 0.5 dB, while the high content CNT only resulted so poor EMI shading performance of the fabric. We also check the conductivity of the materials. The conductivity of the fabric is low. Even after the 50 cycle of assembly, the conductivity was only 0.4 siemens per meter. To solve this problem, we use capillarity-assisted assembly for CNT coatings. For this method, instead of raising the fabric in water to remove the physical absorbed CNT on the fiber, we dried the white fabrics directly and to absorb the CNTs and pH on the fabric, and thus increases the deposition of the film. the mass of the deposition of film was dramatically increased by using the capillarity-assisted assembly. And the CNT content is still very, very high. In this coating, the CNT is still retained at 70.9% in the coating. And what's more, this coating also shows stable washing stability because of appearance of pH. This coating also shows a hierarchical structure where the CNT were coated with the polymer, and moreover, the coating is around 3.9 micrometer thick around the fiber. This thin coating resulted in the flexibility and the air permeability of the coated fabric. These two characters are very important for the practical use for the fabrics. And also, using this method dramatically increase the conductivity of the conductive fabrics. The conductivity of the CNT fabrics reaches 5.3 Siemens per meter after 30 deposition cycles, which is one order of magnitude of the fabric when compared to the traditional layer-by-layer method. And the fabric interact with the electron wave strongly, and the temperature will be increased rate. And the EMI shading efficiency reached 11.9 dB after 30 deposition cycles. The high CNT deposition mass, together with the porous structure of the fabrics, play important roles in the effective EMI attenuation. But we also notice that even with the high loading of CNT in the composite, the EMI shading performance of the CNT coating can be further improved to achieve the high performance for the practical usage of the fabric. And moderate the arrangement of CNT in coating is a promising way. This is because the orientated CNT arrays in the composite can increase the conductivity, as reported in the literature. But how to realize the orientated CNT arrays in the 3D complex textile substrate? This is a big challenge. Here, we use evaporation-induced assembly for CNT coatings. This assembly is completed during the drying process of the fabric. Here, we add the sodium arginate in the CNT solutions. And during the assembly process, there is a convective flow along the fiber angsures, and this flow will induce the alignment of CNT along the angsures, and after the drying of the fabric, angsures aligned of CNT on fibers are repelled. The concentration of the SA is important for the alignment of CNT arrays, and at the concentration of 3 milligrams per mil of the SA, the CNT arrays shows a better alignment than other concentrations. And also the conductivity of the fabrics also should arrangement dependent. And at the concentration of 3 milligrams per mil of the SA, the fabric should better conductivity than other fabrics. Therefore, for the further study, we use the scientists with 3 milligram per ml SA to further study the performance of the fabric. And after the first deposition cycles, the anxious aligned CNT were prepared, and it should well aligned with the anxious of the fibers. Thickness of the coating is 1.5 micrometer, which is among the thin thickness of the conductive coating. And we also notice that at the junction of two fibers, the CNT here is random distribution. Coating here can connect the two fibers to build a conductive network in the CNT coatings to further expand fiber, and we should find that the aligned CNTs contributed to electron mobility in the anxious direction of each fiber. And also, when compared to the random distributed CNTs in the fabric, the well-ordered CNT coatings shows 81 times higher than the random CNTs in conductivity. Also, the fabric shows electrical conductivity is assembly cycle dependent, and after 50 cycles of assembly, the sheet resistance of the fabric reached 9.9 ohm per square, which is comparable to the commercial carbon cloth. It is notable that the carbon nanotube fabrics shows isotropic electrical properties by the IV curve. This is because of the random distribution of fibers in the woven fabrics, and the isotropic electrical properties is important for the practical use for the fabric. Because of the compact structure of CNT composite, the fabric should excellent mechanical stability no matter at different bending angles and with different bending times, frictional times, and stripping times. And this fabric can be stored in the ambient environment for a long time. This coated fabric is habit of good EMI shedding efficiency, and after 20 assembly cycles, the fabric inhabits an EMI SE of 21.5 dB in the X band and 20.8 dB in the cool band, which already meets the commercial requirement of the EMI shedding fabric. This high-efficiency conductive network in the fabric generates an excellent EMI shedding effect with the aid of the multi-reflection behavior of the fabric, and this well-ordered coating interacts strongly with electromagnetic waves. And also, the fabric should have good washing stability after the SA cross-linked. The stability show the practicalness of the fabric. For conclusion, high loading of carbon-based composite coating indoor fabrics with high EMI shedding performance and ordered conductive network encoding is significant for electrical conductivity and the EMI shading performance. The optimization of the structure is one of the most promising strategies to realize the lightweight and high performance, which is two essential characters of EMI shading coating fabrics. At last, I want to thank Professor Chu gave so many suggestions for this researches, and I also want to thank my group members and for their help for this study. And thank you for your attention.
Thank you so much.
Okay. Go ahead, Brenda.
Oh, yes. Do we have any questions, any comments? I cannot view the chat. Maybe Professor or Victor can check if we have any questions.
Brenda, there are no questions in the chat. I've been trying to sort it, but it seems to have been a challenge to me. I've escalated the issue to our colleague on the floating.
Okay.
Yeah. So meanwhile, as we wait for his response, we can just continue.
Okay. Yeah, so the study is good. Maybe we could get any questions.
Maybe I can ask one question.
Okay.
The question is, where is this fabric supposed to be used? And how, I said one, but let me ask two. How serious is the problem of electromagnetic waves on health?
Hello.
I beg your pardon. Your question is how the electron wave interact with the fabric, or
hello, I asked two questions. Where is the fabric that you are making supposed to be used? And how serious is the problem of electromagnetic waves on our human health?
Yeah, I think this fabric can be used in the future to protect human beings. Maybe it can be used for clothes.
Okay.
And another question is,
how serious is electromagnetic waves on our health? We use all these gadgets in our houses. We use, we charge our phones. We have radios. We put them close to our beds. How serious is it?
Sorry, you mean the practical, the flexibility and something like that?
Hello?
Hello.
Hello, have you gotten my question? Can I repeat the question?
Yeah, I didn't hear your second question. I'm sorry.
My second question is, it seems that there is a problem
4 and for the control, and then 5, it increased to 5 on boiling post-mordanting, and also increased to 5 on simultaneous mordanting. As you look at wash fastness, the unmordanted fabric, which was the control, registered excellent of 5 against a standard of 5. And then almost reduced to 4. Again, on simultaneous mordanting, it also reduced to 4. As you've seen, the wash fastness properties, it reduced production from 5 to 4 on simultaneous mordanting and post-mordanting. When you come to rub fastness, two trials were tested, that is on a wet rubbing and dry rubbing. And on the control, that's for ammonia fermentation method, and it improved to excellent on post-mordanting. And also, it maintained, which is also good, and simultaneous mordanting. When you look at dry rubbing, the all grades tested, it was recognized and all tested 5, which was very good. This is what I have just said. The extract yielded different shades of colors on the fabric, from dark brown, light purple, and dark purple. This dark brown was from the unmordanted fabric. It gave a light purple fabric, and then ammonia fermentation method gave out a dark purple fabric. And the fastness rates, as you've seen, range from good to excellent, of 3 to 5 against a standard grade. On wrap fastness, there was no change with fabrics dyed with extracts from an ammonia fermentation method on simultaneous mordanting method, while post-mordanting increased lightly from good to 4 to excellent to 5.
Leonard, you're breaking. We are losing you in between.
Boiling water method is an unacceptable standard grade scale of this fabric are from 3 to 5, of which it all achieved from that 3 to 5. The main findings of this study is the extraction of this natural dye is economical and produces acceptable results. And also their use in textile industries reduces the impact of pollution from their synthetic dyes. So the society will have a treatment, especially to small-scale dyers. And also the environment will be free of pollution from their synthetic dyes. In conclusion, the phytochemical screening revealed the significance of lichen flavoparmale presence of phytochemicals such as flavonoids, tannins, terpenoids, saponins, and fixed oil steroids, and androquinones and alkaloids, which may be the basis of its dyeing properties. Another one is that the extract, along with the mordant, gives better results on 100%. That will recommend further studies to be done on isolation and characterization of compounds identified in phytochemical screening. And also other fabrics, apart from cellulosic ones, needs to be dyed with fabric with dyes from this lichen. The authors would like to acknowledge the Africa Center of Excellence in Phytochemicals, Textiles, and Renewable Energy, that is ACE2 PTRE, for funding this work. Thank you.
Thank you very much, Lynette, for that very good presentation on lichens as a source of natural dyes. Now, participants, she's utilized her time well, so kindly, if you have any questions or comments regarding Lynette's presentation, kindly let us post those questions to her. Through the chat, so far, no comment, no questions. Maybe as we wait for the questions and comments, Lynette, I'm just noting some link, of course, between your work and also the one from the one that Ms. Scholastica presented. And I seem to be having also the same concern, just the same thing I had asked Scholastica. I notice naturally when you buy a fabric, among the things that we are more interested in is in the event that I sweat, that aspect of the perspiration. Your work also seemed to have not included that perspiration fastness, which I really think is also a very major quality. And especially if you're trying out new dyes on, say, a fabric. So my concern is just why didn't you consider the aspect of perspiration fastness? Thank you. Yes, Lynette? Lynette?
Yes? I'm not getting you well, Dr. please.
Oh, I was asking, sorry, I was asking your work, how come the aspect of perspiration fastness as a quality of those dyes that, the natural dye that you extracted was not considered in your study, and yet I think is a very important property when you're trying out any dye and more so the natural dyes.
Okay. As I said earlier, quality in any fabric, that is light, wash, and rub. That's the main three considerations most consumers look at it when they are looking for this fabric.
Oh, okay, thank you. Although for me, it would interest me to really know also the other bits. Thank you, thank you.
Can I ask something?
There's a comment in the chat section. Professor Mosiagi would like to know why, in your presentation, why you're considering synthetic dyes to be bad.
Can I just ask something?
Okay, Professor Mosiagi, kindly ask your question. Kindly go ahead then.
I think the question has been asked, but I want to also clarify that even Scholastica, where I'm a co-author, mentioned the same, plus Vincent. What is coming out is that these synthetic dyes are very bad, they cause cancer, etc., etc. My question is, are we telling the whole truth? Because even I can say without doubt that most of us are now wearing clothes made out of synthetic dyes. So maybe just a comment. And I want to make it very clear that even my own presentation had that. Thank you.
Professor Mosiagi?
Hello.
Hello.
Professor Mosiagi?
Yes, I am done. I asked my question, so I'm wasting.
Okay, thank you. Okay. Thank you very much, Professor Mosiagi, for that comment. Do we have any other question? We still have some 2 minutes. Any question regarding Lynette's presentation? So if there is none, let me also thank you, Lynette. Thank you very much, Lynette, for that presentation. I can see just in the chat, Viola is asking the sustainability, Lynette, what is the sustainability of using lichens And is it so easy to obtain these lichens in the environment? Lynette?
Pardon? I'm not getting you.
We have a question. There's a question that has come through on the sustainability of using lichens. Are they easily available in the environment?
Sustainability.
Of using the lichens as a natural source of dye. Maybe Lynette is not getting the question clearly. I think for all participants, so not clear, let's the chat tab. Some of the questions will be responded in the chat tab. So for our time limit for Lynette's session is over. Kindly allow me to present our last speaker for this session. So the next speaker for this session is Hafezullah Memon. Hafezullah Memon is a teaching and research assistant at Dong University Center for Civil Aviation Composites in China. His main interest, his research interests is in the area of sustainability, polymers, textiles, and also materials. So kindly, Memon, kindly begin your presentation now. Memon, we are waiting on you.
Yes, can you hear me?
Yes.
Yeah, okay.
Please carry on.
Yeah, okay.
Memon?
Yeah, hello?
Yes, kindly carry on. We are waiting on you.
Yeah. Can you see this slides, right?
Yes, the slides are clear. Go on.
Hello, Chair.
Yes, Rachel.
I've seen it's like Memon has left. I think he has some challenges.
Okay, okay. Maybe participants, let's just maybe give Memon about a minute or two. I think he's having the challenges with the connection, and then we can proceed.
Yeah. Hello, can you?
Yes, Memon, kindly.
Hello?
Hello, Memon, can you hear me? Okay, kindly carry on. Please carry on. We are waiting on you.
Okay. So my name is Hafizullah Mehman. My topic is high-performance bio-based epoxy retrimer with closed-loop recyclability and its application in carbon fiber reinforced composites.
Excuse me, Memon. Kindly share your slides.
Yeah.
Share your slides.
I am sharing the slides. Is it on?
Yes, please.
Okay. Okay, thank you.
If okay, you can put in the slideshow mode.
Yeah. Now maybe okay. I think now it seems okay. So my name is Hafizullah Mehman, and this is my topic: high-performance bio-based epoxy retrimer with closed-loop recyclability and its application in carbon fiber reinforced composites. So these are the contents for today's presentation: that the introduction, material methods, results and discussion, and the conclusion on the topic. So we all know that the carbon fiber reinforced composites are the promising material for the textile composite industry. So for making carbon fiber reinforced composite, we mostly use the epoxy resin, that is the 70% of total thermosetting resins. So these epoxy resins are insoluble, and they are able to they are insoluble, and and we cannot reprocess them. Once the structure is formed, it remains forever. So this idea in this my research that I'm going to present today is discuss about the epoxy resin that is insoluble, and as well as it is able to process, like we can reprocess it, we can recycle it similarly like the thermoplastics one. So the bond, what is the chemistry behind this? It use the dynamic covalent bond, the bond that can disrupt and reorganize itself. So this resin is like thermoset as well as thermoplastic. We have also focused on one more idea in this research, that this resin was obtained by the bio-based resource, that was the lignin, and using lignin we use the lignin dry vanillin to synthesize this novel epoxy structure, and we make the composites from it. So this idea is actually coined in 2010 by Bauman Research Group, and they call it the covalent adaptable networks. And then it was further extended for after 1 year from Philippe Duperret's group, and they give it the work on the reversible click reaction. And in 2011, Professor Ludwig Lebler from France, they have been working, and they termed this new material as a retrimer, and they have been working on transesterification reaction to make this promising material. Professor Changwe et al. From USA, he has also been working on it, and these are the famous key research groups that are working on this in this area. But what is the problem in this research group? That they could only get the glass transition temperature, like Rindo et al. From Italy, they only could get the glass transition temperature to 90 degrees centigrade, and they could not get a higher glass transition temperature while promising their performance. Like it should be a recyclable as well as a high performance, or there was some limitation in the research. So in China, it has also been work in many research groups, including Tsinghua Tongkha University and from in Guangzhou. So in Tsinghua University, they make many functional, many activating functions that can obtain, like this what they made a new type of a trimmer, they call it oligoaniline, and they had 6 different functions like welding, recycling, healing, electromagnetism, and electrochromism and shape memory. So in Tongkha University, they also worked before, but the problem remains same, that the glass transition temperature was not as high as it could be used for advanced application. So here are the materials that we use for the synthesis of this new structure and new epoxy resin. And these all materials were sourced from China locally, and these are some equipment that we used. So this is the synthesis scheme. We used the vanillin, that was the bio-based and bio-derived lignin-derived compound, and we reacted it with HTDA, and we produced VBI HTDA like vanillin-based imine based on the HTDA. And then we reacted with mixed epoxy, like mixture epoxy, diluent epoxy, to get the coupon, and the curing scheme is also presented here. 80 degrees centigrade for 1 hour, 140 degrees centigrade for 2 hours, and 170 degrees centigrade for 2 hours. So here are the curing peak and curing temperature for this, that how much temperature was should be given to cure this reaction. So we used the DSC, and the structure was confirmed by FTIR. The structure VBI HTDA was confirmed was using if the imine bond is formed. So if we see that the 1663 and was actually the point that was for aldehyde, and 1640 it is for the imine bond. So we can guarantee that the reaction is successful and there are no aldehyde peaks remaining in it. Also, we confirmed it with HNMR. We used we analyzed this structure because it's shown in the scheme that there were the two types of A and B. It was the structural monomers of this VBI-HTDI in the during the synthesis. So we also determined what was the ratio of A versus B, like it was a 59.5 and 41.5 that we calculated using HNMR. That there are the two main compounds. So and then we also did the dynamic properties analysis. Also we did the CNMR analysis that is shown here, and then we also work on the work. Sorry, this PPT is just stopped.
Memon, try exiting from the slideshow mode.
Sorry, this. So we did the CNMR for this to guarantee the reaction has occurred, and then we assessed the dynamic properties of the cured coupon, that it has high activation energy as well as a high glass transition temperature, while the Wittremer transition temperature was 54.34 degrees centigrade, but the glass transition is quite high, it's like 131 degrees centigrade. And this is the video that we also reprocess it because to guarantee that it has a self-healing properties. So we can refer to this video. You can see that how we make this recyclable. First we crush the resin and then put into the mold, and we fill this mold and put in the like hot press for a certain time, and then the coupons were taken out. So this was the scheme, and it could be recycled. So I hope this video can give more clear idea about what we have done. The resin sample was taken out, and this was polished to test again the tensile strength properties of the sample. and the sample was tested for the tensile test. So we repeated this process several times, and we believe that small powders and large powders were combined together to make a recycled coupon, recycled sample. So these were the mechanical properties, the mechanical reprocessing property of the cured resin, that for the pristine one, we could get the 82 megapascal of the strength, and in the second cycle, like in the first cycle, it was decreased to 73, and it was further decreased in the second and third respectively. But overall, if we see the number of after the different number of reprocessing, we get enough high strength, like 88.42 strength self-healing efficiency, which was quite high, and 76.95 for the second cycle and third cycle. So also we determined the mechanical reprocessing of the cured resin, and we determined the DMA, that was there any change for in the glass transition temperature as well. So there was a slight very negligible change in the glass transition temperature, but there was a smaller change in the storage modulus, because after the different heating recycles time, the resin was going to be brittle, like more brittle. And this is the full recycling process for the CFRPs, carbon fiber reinforced plastics. Like what we have done, we dissolve this coupon into the resin, and we extract this out, extract the carbon fiber out, and test the ACM, that whether we can reclaim the carbon fiber from the composites. Also, we boiled out the solution, and the powdered resin was tested for its tensile strength. So also we tested the chemical recyclability of the resin by adding more monomer inside it, and this is the chemical recyclability scheme, that the broken coupons of epoxy resin were dissolved again in HTDA and more amount of aniline and AFG90, the epoxy resin and the catalyst was added to get, and the distillation of ethanol was guaranteed, so that it can be a fully closed loop recycling. This is the chemical recyclability results. If we say that the regenerated resin was not enough better, but the recycled one is quite similar as was the pristine one. Also, we did on the enduring prepregs, because for the carbon fiber reinforced industry, the composite industry has several issues with the enduring prepregs, that the life of prepregs is not enough high. We need to store them in cold storage. That is the additional burden on the cost, as well as the additional burden on its for its processing. We cannot use it, and the waste of the prepreg industry is very high, so we can use this prepregs for making the composites. So these were the prepregs that was like the two type of composite coupon. One was from uncured prepregs, and the second one was from cured prepregs, and we get almost similar interlaminar shear strength. And this resin had a good solvent resistance, and we can see that it lasted for 96 hours in different solution, including acid and alkali. So it has a very good solvent resistance as well, and also it has a very good thermal stability. We did the thermal stability analysis, that the char percentage was quite similar for the process regenerated. So we can say that there was no chemical change in the structure. It was just the shuffling of the bonds to be recycled, whether it is a regenerated, recycled, or even reprocessed.
Memo, you have about 2 minutes.
Sorry?
2 minutes, kindly wind up.
Yeah. So these are the conclusion, that bio-based and tensile strength was higher as 82 megapascal, and the glass transition temperature was 131 degrees centigrade with retention efficiency of 90%, achieving almost 100% closed loop recycling, and the additional benefit was the thermally stable and solvent resistant with enduring prepregs. So this is my research proof that I have been working here in Tonghua University for more than around 4 years, and including my professors and co-supervisor. And so this is my end of the PPT. I believe that if any question or suggestion is warmly welcome. Any question?
Thank you very much, Memon, for that insightful presentation. I now welcome any comments, questions, or reactions to the presentation that Memon has given us. Any question? Through the chat box, I'm still not seeing any comment or question, and maybe just in we have about 3 minutes for this session.
Any question?
Maybe I may ask you a question, Memon.
Yes.
Is there a difference between these bio-based and say the non-bio-based, like the petroleum-based epoxy resins in terms of properties like thermal, mechanical, and even recyclability?
We have already one published paper comparing the bio-based and petroleum-based one that is recently published in Macromolecules, and it's a very interesting paper. And this question is very interesting. I can share the link of that paper. Maybe some of our participants in the conference would like to read that paper, and this paper is. They can refer to that paper. This is a different complete study that is recently published by our group. So I'm sharing this the link in this. So we have already compared.
Okay.
I have shared the link. It's very interesting study and recently published in the Macromolecules by American Chemical Society.
Thank you very much. There is a question in the chat box. Vincent would like to know
if the resin is toxic. For the question from the Professor Vincent, that the resin is not toxic because we have used a bio-based material, and vanillin itself is like a plant drive, like is a bio-based. So we cannot say that it's a toxic. It's much safer. But further test should be done to guarantee that it's a non-toxic. We have not done for we don't have done any test that I claim that it's a non-toxic, but it is not at least toxic as we can assume from its structure.
Okay, thank you very much. I think we are just coming to the end of our session, and I really want to thank all the participants. I think from the 5 speakers, we've had a chance to listen to what we've been told about the health benefits of garlic, and then also the good properties that the various plant sources
established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory Authority. EPRA is established under the Energy Act 2019 and regulates electrical power, renewable energy, and petroleum subsectors. EPRA's expanded mandate includes the regulation of upstream petroleum and coal. EPRA protects the interests of energy consumers and ensures that all players in the energy sector adhere to set business practices. We are here to facilitate access to sustainable energy for all. EPRA, quality energy, quality life. The Energy Regulatory Commission is now the Energy and Petroleum Regulatory.
In the lower left picture, you see an antenna and it has a hole in the middle. By inserting a hole, we can drastically broaden the bandwidth. And this is something that you can clearly find by running the simulations. So this is how the simulation is really helpful for creating good antennas. The fabrication was by embroidery, lamination, and printing, and the testing is done in an anechoic room, of which you can see a picture here. It has no specific textile requirements. Well, the standards have no specific textile requirements because a standard antenna, a common antenna, doesn't have any textile characteristics. So there are no prescriptions regarding the clamping or the room conditions, temperature, humidity, etc. And also the number of repetitions is not mentioned because the variability of a standard antenna, a common antenna, is way less. But for textiles, this is really important to take it up in the research. Then we also do some work on thermoelectricity. It has been explained already in the previous paper, so I won't repeat. The start of the work has been the thermocouple with copper and nickel materials. The PhD student working on it is Hardianto, and he will defend his PhD next week. So should anybody be interested in joining the presentation, please send me a message and I can forward you the link. It will be online. So the concept we have chosen is a wire which is coated in dedicated intermittent areas with a second metal. So we have a conductive core coated with a coating at regular places. As you can see here, how it is inserted in the fabric and how it is produced. The materials used, well, these are the materials we have studied. So stainless steel, carbon fiber, nickel, polypyrrole, copper, and silver, and constantan. And in the right graph, you can see the various effects that have been achieved. Most of them are pretty much in line with what has been, what could be expected based on the Seebeck coefficients of the material. And you can see for the textile materials, relatively good outcomes, power outcomes can be achieved, although the constantan is the better one, but it's also not an easy material to work with, and it's not fully compatible with the textile processes. The textile structure, we have used carbon multifilament as a conductive core and nickel as the second material. The Seebeck coefficients of the materials are 3, and they should be -15. So we can expect a theoretical output voltage of around 18. And the carbon fiber has a moderate conductivity, which is needed to make sure the current is passing through the nickel coating in the dedicated area. And this allows to create such a thermoelectric effect by using a textile yarn inserted by a regular weaving process. The coating can be achieved either by local etching of a nickel coating on a nickel carbon fiber material, which can be just bought commercially via the internet, or by local electroplating of the nickel onto the carbon fiber multifilament. How did the models help us here? Well, first, on a material level, just give us an idea on the maximum achievable output. The material impact, both considering the conductivity of the materials as well as their Seebeck coefficients, the dimensions of the whole system, and then for the modeling, we needed to do some simplification, but we also managed to show that the simplification of the multi-filament into a monofilament with the same cross-sectional area of the carbon fiber and the nickel coating is allowed. It doesn't have an impact as long as a good contact can be guaranteed. And then also effects of the transition zone. You always have a transition between the carbon and nickel-coated carbon. In an ideal case, this is 100% sharp, and there is no nickel in the intermediate layers. But with the modeling, we can estimate what would be the effect if this is not the case. Also, the effect of imperfections and local defects and inhomogeneous areas are to be included. Selective etching, here you can see some results. We had to elaborate a method for the etching because there was no literature. And here you can see how by increasing the concentration of peroxide, how the nickel is disappearing and how the carbon layer, the carbon core becomes visible. And in the right figure, you can see the resulting thermoelectric voltage as a function of the peroxide concentration. And you can see that as from a concentration of 10% peroxide, the nickel layer is fully removed, or at least it is removed up to an extent whereby you have an optimal functioning of the system. Then integration in a textile. Here the yarn has been inserted by hand because the etching has been done at the level of the fabric, and we achieved a thermal voltage of 16.7 microvolt compared to a theoretical maximum of 18, which is an efficiency of more than 90%, which is quite good. And the total voltage can be increased by having multiple pairs in series, which is a linear effect actually. The nickel coating has to be optimized because, of course, if the coating is not properly done, the outcome will be lower, and in some cases it can be as low as 3 microvolts. So it's really important to work on this in order to have a good result. In the right picture, you can also see how the voltage is increasing as a function of the temperature difference. It's a linear relationship, as could be expected. And here you also see that the model corresponds quite well with the experiments, and that the concentration of peroxide of the etching solution should be at least 10%. Then the testing. Well, the testing includes the functional properties and the textile use. And here also we had to develop methods for measuring the voltage and for creating the hot and the cold side of the fabric. So we used the hot plate and we allowed it to cool in air. So the ambient air was the cold side. And then to conclude, first general conclusion is that the energy scavenging as well as storage can be done by textile structures using textile materials and textile processes, and various principles are feasible. We heard in other papers that other concepts are feasible as well. We need an energy management strategy because energy is scarce and it's not easy to supply sufficient energy for powering a complete system. Modeling is useful, very useful to support the design phase. Test methods lack or need adaptation, and actually in November there will be an online conference on the topic of testing smart textiles and standards. Energy solutions largely depend on the application. Just remember the baby suit, whereby for newborns, the inductive solution could be proper, but for elder babies, this is not feasible anymore. And reliability is an issue. The conditions of textile use are really harsh. We sit on them, we stretch them, we bend them, we throw them in a washing machine with water and chemicals. So this is always a point of attention. So with this, I conclude my presentation. And if there are any questions, you can always ask them or contact me later, send me an email or a message, and I will try to help you. Thank you.
Thank you very much, Professor. Professor Liva van Langenhoven is a professor of functional properties of materials at Ghent University in Belgium. I would like to invite questions for her presentation. Do we have any questions for Professor? Thank you very much, Prof. Apparently, we have no questions at the moment, but like you have said, we can all channel our questions to your email address.
Yep, okay, no problem. And yeah, I would also like to congratulate the organizers for organizing this conference. I know it was supposed to be a physical conference, and I was really looking forward to visit your beautiful country once more. But in spite of the difficult situation, I think we still can enjoy an interesting program and learn a lot about novel developments in engineering. Thank you.
Thank you very much, Prof. We have challenges, but the challenges also give us new opportunities, so that we find that we are able to communicate and see results and share results of various activities. Thank you very much.
Thank you.
Okay. We have been listening to the keynote speech by Professor Liva. We will now go back to our program. And after the presentation of thermoelectric textiles, we go to the presentation on fabrication and acoustic performance of natural cellulosic fabric reinforced epoxy composites for musical instruments. This one will be is a paper by Fanshizi Liu. Fanshizi Liu, are you ready?
Yes, can you help me?
Please go ahead and give us your presentation.
Okay, thank you.
If it's possible, you switch on your video so that we can also come close to your presentation, if it's possible.
I'm Fanshizi Liu, a PhD student in the textile. My superior is Professor Yiping Chou. My research direction is green textile composting. I'm honored to be able to share my work with you. The subject of
just a minute, please.
Vibration and acoustic performance. What?
Hello? Is it possible for you to switch on your video?
Yeah.
So that. Okay.
Can you see my video?
I don't see your video.
You can't see my video?
Please switch it on.
Fibers reinforced. It's okay?
Okay, just go ahead.
Epoxy composites for musical instruments. I will introduce my work from 4 aspects. Jump is the most important musical instrument of Chinese. There are more than 100 albums about drums. It presents an important cultural heritage of the Chinese nations. However, due to the large volumes of drums, it's impossible to board trains and airplanes. The transportation is very inconvenient. Moreover, a lot of wood is needed to make drums, but the forest is a very precious resource. To make 800,000 drums a year requires 400,000 square meters of wood, and 2.3 million 10-year-old trees will be cut down. If not, the carbon emissions of 618,000 cars can be reduced, which is very important for environmental protection. President Xi Jinping said local water and luscious mountains are invaluable assets. But there are thousands of rivers and mountains between them. How to replace wood with a musical instrument is our job. Using composted materials, such as man-made fiber and vegetable fibers reinforced composites to replace wood is in musical instrument has been attempted. It seems that composites are reasonably qualified for replacing wood in some of the musical instruments. In order to replace wood with fiber-reinforced composites in this instrument, acoustic emissions properties of composites have to be studied and compared with their old competitors. Drums need to meet some protections, such as metrical acoustics, dramatical stables, and processability. Especially the acoustic performance, we use 3 indicators to evaluate it, which I will talk about later. In our studies, 4 types of epoxy resin composites reinforced with the fabric of hemp, flax, ring, and drift, respectively, are fabricated using Van-Campbell-Asian's resin infusion model, VARIM. The tensile presentations of the composites was tested using a universal test machine instrument according to the ASTM D3039 standards. The flexural properties test was performed to the same machine according to the ASTM D7264. It can be seen that the strengths and models of 4 composite materials were larger in the weft direction than those in the warp directions, because the weft yarns were thicker and the weft fabric counts were larger than those of the warp. The extrusion of the wood were particular variables, and the flexural strengths and the models of 4 composite materials were in between those of the vitreous and the horizontal strips of the anthers. The crimps of warp and weft yarns in the composite materials could reduce the uniformization of the strengths and models of the yarn in the composite materials. It's obvious from that the web crumbs of the 4 fabric composites were signified larger than those of the weft. Among them, hemp and flax weft yarns had a little crimps, ensuring a high rate of the fiber strength innovation, and the crimps angles of rim and jute were young weft yarns were about half of those in the warp yarns. This could effectively increase the tensile strength and models of the composites in the weft direction. The acoustic resistance and the reaction special characters of a material could be important indicator to evaluate whether it can be used as an antenatal materials for musical instrument. The special dynamic models ED rate row acoustic radiation diametric coefficient R, acoustic impactance Z, were calculated as shown. The acoustic properties of four composites were between those of horizontal strip and the vertical strip of the enanthers. Since the flexure model of the composites was lower than and their density was higher than those of enanthers, their acoustic dynamic models and acoustic radiation dynamic coefficients were lower, and the acoustic impactors were higher than those of the wood. The resultant frequency of the composites and the enanthers all range from 0 to 5 kilohertz. And for all the natural frequencies of the composites were between those of the horizontal straight and the vertical straight.
Hello? Hello? We appear to have lost you, Francis Liu. Are you there?
Okay, I'm here.
Okay, continue.
Yeah, it's okay?
Continue.
Sorry, Chair, but we cannot share the PPT.
Yeah, it's still.
I can't hear you. I don't know if others can hear you.
Guys, can you hear me?
Sorry, we cannot hear you.
Okay. I will share again.
Hear your voice, but no audios from your video.
Okay.
So will you continue with the presentation?
Yeah.